Another video for the series, and today I brought a problem from APMO, and I actually solved this problem, and then I compared my solution with the official solution, and I realized that the solutions are identical, but mine was just phrased quite differently. So that's why today I will just share my solution, because I think I can explain my thought process more explicitly if I explain with my personal solution. So this is what I did. So first, after realizing 1, -3, and 3, and then also like the exponents, I immediately thought of rewriting it. So I can rewrite this as 1 minus x to the x sub I cubed plus x sub I cubed, and then what I did is I was quite stuck here, so I substituted this thing into the expression. So I have 1 minus I over 101 cubed plus I over 101 cubed, and our numerator should be I over 101 cubed. And then I multiplied by 101 cubed, so we get I cubed, and then minus I cubed plus I cubed. Now, at first I was like, and then I wrote my expression with sigma, our sum notation here, but I was also quite stuck. That's why I naturally thought of this thing, and the reason is because when we have 1, then maybe that might reduce our burden of using our sum notation, because if we add 102 times, because our initial is 0, we get 102. So that's why I thought of doing it. But then I realized that when we add them, we can make our numerator and denominator both like they somewhat mirror, like when we substitute the values. So that's why I thought of writing it like this: 2s equals 2 times the sum of equals 0 from 1, and then we have 1 plus I cubed minus, and then notice that our denominator are the same. Yes, this is what we can do. And naturally, I think, oh wait, sorry, we should not have 2 here, because we already add them. So here what we can do is notice that, so let's say let A and B be, I'll say, whole numbers, such that A plus B equals 101. Then what we know here is, let's try and substitute our A and B for I. A cubed minus A over 101 minus A cubed plus A cubed. And then when we add the value that we substitute for B, then actually the reason why I thought of this is because notice that, like I mentioned, that when we add them, then it somewhat cancels the other terms. So it somewhat mirrors the situation. That's why I thought of this, and this is actually equal to 0, because let's write everything in terms of A first. We can write it like this: plus 101 minus B is equal to A. So A cubed plus b is 101 minus 8. And notice that we have the same denominator. And then for the numerator, we can assume that the same thing will occur. So our b is 101 minus a cubed minus a cubed. So these two cancels each other, so we get 0. Therefore, we know that when we pair things up, we have like, I'll write it here, 0, 101, 1, 100, and then until 50 and 51. Meaning, all of these terms will just be 0. So we have 102, and notice that this is 2s, so therefore our s is equal to 51. I had to take a few moments when solving this problem. I think I took around 30 minutes to come up with this thing. And I think the first kick is, I don't think there was like a strong kick for this problem. Everything just turned out to be like flawless. Like, I think it's quite natural to think of this thing and then from here to here. But I think trying to write 2s, that was our first kick. Then naturally we find the pattern and then we can get our answer. Thank you so much for watching this video, and I hope this video was productive. And tomorrow I'll come here again with more interesting and fun problem. So I hope you enjoy. And thank you, and see you tomorrow. Bye.